Hello, some of you might have seen that it is actually a second take because I recorded the first video muted. Suffering. Okay, so first of all, I got myself a stylus so I can actually write efficiently now. That's for one. For two, and I spent some time configuring it, so yeah, now it's gonna be something frequent on this channel, regular, and we have this problem today. We have this limit. We have to show that is equal to 1, given that we have f of x, a function that is approaching 1 and has an asymptote like that. Alright, so first of all, we need to gain intuition for this limit. How do we do that? Well, you can observe some relations. First of all, let's say that f of x is equal to 1, though it isn't, and I relate the limit like that. So limit is t approaches 0, the integral from 0 to infinity of t times e to the power of minus tx dx. Next we can just bring out the minus, and here we can do a u-sub. So we get from 1 to 0 of 1 dx. Now the minus just reverses the order, so we get just 1. And that's what is equal to when we have f of x is just 1, but that's not the case. So what more developments do we have to acquire? Well, if we were to look at this thing, let's take this integral and separate it into two. For example, from 0 to a, plus from a to infinity. And if we were to look at the limit as t approaches 0, obviously when we separate it like that and discard this part, then this is going to be a different thing. But after we apply the limit, it's going to be the same thing as we have this thing. Like, we don't care if it's present here. Why is that? Well, let's go ahead and write it down. So we have integral from 0 to a of t times e to the power of minus xt f of x dx. And now the thing is that e to the power of minus xt is always less than or equal to 1 and greater than 0. And next we have t, which we just leave it like that for now. And next thing we have is f of x, which is gonna be bounded because it converges what do we have here? F is Riemann integrable, so yeah, it's bounded for sure. Alright, so less than equal to some m. Alright, so this integral is gonna be what? Te minus xt f of x dx is gonna be less than or equal to okay, let's take the epsilon here, less than or equal to m times what? Times t. And as we take the limit, t approaches 0, what we get is this thing over here. But absolutely that's less than or equal to 0, so it's gonna be equal to 0. Alright, so now having this information, what this implies about the behavior of this limit is that, first of all, we can start integrating from any lower bound that we want to pick. That's for one. And for two, is that when f of x is equal to 1, we can evaluate this limit easily, it's going to be 1. So what I can do is, essentially, I can introduce an error function, let's call it delta x, let it be 1 minus f of x. And what we're going to do is we're going to show that the error function is going to make the other part of the integral insignificant as we take upper and upper bounds. Alright, so this limit over here was copied over. Is going to be equal to limit as t approaches 0 of an integral which will start from, let's call it b, to infinity, e to the power of minus tx, also t here, f of x dx, and instead of f of x, let's write it down as 1 minus delta of x dx. Now we evaluated the integral for when it's 1, that's going to be 1. Alright, and next thing that we have is minus delta x. So minus limit as t approaches 0, the integral from b to infinity of t times e minus tx times delta x dx. Now, thing is, we need to show that this is going to be equal to 0. How do we do that? Well, what we can do is we can work with this lower bound here. We can say that, well, for every epsilon greater than 0, there exists, let's call it m capital, such that for every x greater than m capital, delta of capital's epsilon value is going to be less than epsilon. Alright, and now given this, let's work with the limit is t approaches 0 from b to infinity of t times e to the power of minus xt delta x dx. Now, reviewing this integral apart from the limits, what we will get is we can look into its absolute value, because, well, if its absolute value is 0, then obviously the actual thing is also going to be 0. So what we can do is we can show that the absolute value is less than every positive number that we can pick. How do we do that? Well, we can use a bunch of nice inequalities. First of all, this integral is going to be, the absolute value of this integral is going to be less than the integral from b to infinity of the absolute value of the integrated function. So this is our first transformation, and next thing we're going to do is, well, delta of x is going to be, absolute value of it is going to be less than epsilon. That means that the integral from 0 to infinity of epsilon times the integral from 0 to infinity of t times e to the power of minus xt dx is going to be greater than this thing. Alright, and now we, I wrote 0, it's b here. Now let's actually evaluate this integral, and we bring out the minus here, then we do u sub, so here we bring out the minus, infinity becomes 0, here we have e to the power of minus bt, then we bring out the minus back, so e minus bt is here, and 0 is here. Alright, so what we get is epsilon times e to the power of minus bt here. This is what we get, and now as we take the limit where t approaches 0 of the integral from b to infinity of t to the power of minus xt delta x dx, and let's take the absolute value of it. It's gonna be less than or equal to the limit as t approaches 0 of this expression, which is going to be just epsilon. Alright, and now given this, what we can say is that, well, for every epsilon greater than 0, the absolute value be to infinity. I won't write down it here, you know what is located there, and it's going to be less than or equal to epsilon. And what this implies is that the integral from b to infinity of t times e to the power of minus xt times delta x dx is actually equal to 0. The limit specifically, of course. Limit as t approaches 0. Alright, and also limit here too. I don't know why I didn't write it down, but yeah, you get what I mean overall contextually. So yeah, now that we have shown that this limit is equal to 0, we can backtrace here, and well, this part over here is gonna be equal to 1. So I have solved the problem. That's it for today. Bye.